what this has done is it's given me some idea about which numbers can be written as a sum of 4 consecutive numbers. And it's numbers which are 2 more than multiples of 4. If we think about the multiples of 4, let's start at 40. Actually, let's just think about even numbers. So we have even numbers. If I take the even numbers which are in the 4 times table, I can halve them again. If the numbers in the 4 times table, it can be shared, it can be sort of split up into 4. So I can halve that, 20, half that is 10. I can halve that, 22, half again is 11. Half that is 24, half that again is 12. But what you were saying is, these even numbers are special, because when you halve them, you get an odd total. Half of that is 21. I can't halve it again. Half of that is 23. I can't halve it again. So these are the numbers which are 2 more than multiples of 4. So this diagram hopefully helps you understand why I can write numbers which are 2 more than multiples of 4 as 4 consecutive numbers. It means that if I've got a very large number, which is 2 more than a multiple of 4, let's take 880, I know divides by 4. So let's make it into 882. I can now use this model to figure out, well, I know that I can do it as a sum of 4 consecutive numbers, and I now know how I can go about doing this. I've got 2 that are going to go there. That's going to leave me with 880. I'm going to share the 880 between those 4 bars. 880 divided by 4 is 220. I also know that that's going to be the height of the second number. Notice here that the 10 stayed. So a quarter of 880 is 220. So that's going to be my second number. So my first number is going to be 219, and the next 2. And I hope one of the others will correct me if I've made a mistake. But I think that's right. So the fabulous thing about noticing, the generalizing that you've done, is it gives you some indication of what's going on. The fantastic thing about images like this is that it helps you then work out without having to sort of try again and again as you get closer and closer to the answer. Now, there was a young man there who was using algebraic notation. So let's look at this. So you might be wanting to describe 4 consecutive numbers as a plus 1, a plus 2, a plus 3. So we don't know what a is. It's a variable. It can be any number you choose. The next number is 1 more than a, the next one's 2 more than a, the next one's 3 more than a, and so you have 4 consecutive numbers. Now what happens if we add them? If we add them all, we get 4a plus 6. Does this tell us the same story that the diagram told us? Because this is a multiple of 4, what does adding 6 do to this? Well, what we can do is split 6 into 4 plus 2. And now we're getting the same result. We've got a multiple of 4, plus 4 gives us the next multiple of 4. Plus 2 gives us 2 more than a multiple of 4. That's exactly what we're getting here. The other nice thing that this does, but perhaps this doesn't do quite as well, it also tells me that these 2 numbers in the middle add up to the same as these 2 numbers at the end. So in the middle I've got a plus 1 and a plus 2. At the end I've got a and a plus 3. If I add these together I get 2a plus 3. If I add these 2 together I get 2a plus 3. Now why is that useful? Well, it's useful because when you give me a number like 42, I think to myself, if I halve it, I then know what my middle pair's got to add up to. So 42, halve it is 21. Oh, I know what 21 is. 21 is 10 plus 11. And that also tells me that the 2 numbers on the other side add up to 21, and that's going to be 9 plus 12. So the algebra sort of tells me something that perhaps this didn't do quite as well. It gives me some idea about how the numbers work with each other, but it also gives me a strategy for working these numbers out really, really quickly. So let's do the 882. So we have, I'm going to halve that, and that's going to give me 441. And now I'm thinking, okay, so the middle pair has got up to 441, so that's 220 plus 221. And now I know that if I take one away from here and I add one onto there, I'm going to get another 2 numbers that also will add up to 441. I would talk about mathematicians being lazy, and this is sort of a form of laziness. I don't sort of have to do any adding anymore. And you've worked really, really hard here, and it's been a little, and it's very messy, as it should be. It should be, because when you first work with numbers in this way, and you explore, you try to find things out, you don't see the patterns. But eventually, you see the patterns. It sort of makes sense. It all falls into place. So what I'd like you to do now, then, is I'm going to give you some more time to work with this over the algebra to try and explain some of the things that you found. You may be either wanting to use either the grammatic representation or the algebraic representation to perhaps predict things that you haven't found yet. So, for example, you may not have found any numbers that can be written as a sum of 10 consecutive numbers, but we know that they exist. So you may want to play around with the algebra, predict what's going to be special, and then see whether you can find examples where they work. You may want to think about why is it so difficult to find numbers that can be written as the sum of 4 consecutive numbers and 6 consecutive numbers. So here we had some examples where numbers can be written as the sum of 3 consecutive numbers and 6 consecutive numbers, or 3 and 5. Why are 4 and 6 so difficult? Or you may want to be thinking about which number between 1 and 100 can be written in the greatest variety of ways. Or you may be wanting to think about the 16 and 2, which can't be written as some consecutive numbers, or any other numbers like that. There are a whole host of questions that you could be asking yourself. Try and use the diagram of the algebra to help you, and have a go at whichever question intrigues you most. Good afternoon, everybody. Welcome to the Centre for Mathematical Sciences. Welcome to Thinking Mathematically. This is hardly going to be a talk. It's going to be an invitation to you to come and work like mathematicians for an hour. Hence the paper and pencils on your benches. So when we think about poets, we think about people playing with words, playing with images and metaphors. When we think about musicians, we think about people playing with notes and chords, with rhythm and tempo. When we think of artists, we think of people playing with colour and texture and form. In that spirit, I'd like to invite you today to play with numbers. And in particular, I want to think about numbers that can be expressed as the sum of consecutive numbers. So, let me give you a few examples. Perhaps somebody could give me a number to start with. Something, I don't know, between 10 and 40.
31.
31. Okay, so 31 is a really interesting number, because it can be written as the sum of 2 consecutive numbers. It's 15 plus 16. You also had your hand up there. Can you give me another number? Somewhere between 10 and 40 is 30? 13. Okay. 13 is also an interesting number. It can also be written as a sum of 2 consecutive numbers. It's 6 plus 7. Can I have a couple more numbers? Yes.
38.
28 or 38? 38. 38 is really interesting. Because it can be written as a sum of 4 consecutive numbers. Yes? 2 is a really interesting number. Consecutive numbers. 15. Incredibly interesting. It can be written as a sum of 2 consecutive numbers. But it can also be written as a sum of 3 consecutive numbers. It's 4 plus 5 plus 6. And it can also be written as a sum of 5 consecutive numbers. It's 1 plus 2 plus 3 plus 4 plus 5. So you've managed to give me lots of really interesting numbers. And here we go. One last interesting number. 27. 27 is really interesting. It can be written as a sum of 2 consecutive numbers. But it can also be written as a sum of the 3 consecutive number. And it can also be written as a sum of 6 consecutive numbers. Am I going to be able to do this? Thanks for that. I want to give you 5 to 10 minutes to see whether you can write them as a sum of consecutive numbers. And what I'm hoping you'll do is, as you go choosing your numbers and writing them as some consecutive numbers, you'll start noticing some similarities between numbers that can be written as 3 consecutive numbers or 4 consecutive numbers. So So be on the lookout. When we come back together, I'm going to ask you perhaps to share some of the general patterns that perhaps you've noticed. I'm hoping you have paper and pencil. I've got a very helpful assistant there at the back. If you have a missing paper or pencil, just wave your hands and he'll come round and provide what you need. Enjoy. I'm going to stop it. Okay, I think this might be a good time to just stop for a minute or two. We had some late arrivals, so it might be quite nice to be able to explain to them what we're doing. But I'm also quite curious to know what you've been discovering and finding out. So, first of all, just to explain what's on the board for the new arrivals, we've been trying to find ways of representing numbers as the sum of consecutive numbers. So 15 is rather special because it can be written as the sum of 2 consecutive numbers, it can be written as the sum of 3 consecutive numbers, it can be written as the sum of 5 consecutive numbers. And I'm curious about one other thing, whether you've noticed anything in general as you've been trying to find numbers that can be written as the sum of consecutive numbers. Okay.
Why does 16 not work?
Brilliant question. So, first of all, we need to establish that 16 doesn't work. So, 16 and 2 can't be written as the sum of consecutive numbers. The proof of that is slightly tricky, so I'm leaving that for the last 5 minutes of the session, but I will come back to it, because it seems to me like it's a beautiful proof. Yes?
All odd numbers can be written as the sum of 2 consecutive numbers.
Okay, so I can say that again, just in case you didn't all hear. All odd numbers can be written as the sum of 2 consecutive numbers. And what I want to do is now look and say, oh yes, here are 3 odd numbers and they were written as the sum of consecutive numbers. That looks plausible. Yes?
I think that any multiple of 4, which isn't also a multiple of any odd number, cannot be written as the sum of consecutive numbers.
Okay, say that again.
I think that any multiple of 4 that isn't also a multiple of an odd number cannot ever be written as the sum of consecutive numbers.
Okay, any multiple of 4 won't be a multiple of an odd number because... Sorry, what am I saying? Give me an example.
Like 16.
Okay. Have you got any other examples? Okay. So something about multiples of 4, which are not multiples of an odd number. So 28 is a multiple of 4, but it's also a multiple of an odd number. It's a multiple of 7. So this can be written as sum of consecutive numbers. Is that what you're saying? Good. Yes, I think this can be written as the sum of 8 consecutive numbers, but I...
I'm saying that if it's not a multiple of an odd number, then it can't. But that has got either a multiple of an odd number.
Then it can. Yes, I think I agree with you. Yes.
If the number is divided by 2 and creates an odd number, but when dividing by 2, you can express it as a sum of 4 consecutive numbers.
Okay. I'm going to come back to that one. So we only have an example, but I want to show you that. Yeah.
The odd number, like on the board, 13 and 15, the last number is 13, which is 7, will be used as the first 15.
Okay, say that again.
So on the board,
Yes.
6 plus 7, 7 the last number, will be used as the first.
Okay, so if I went to the next odd number, 17, I'd use 8 and 9. And for 19, I'd use 9 and 10. So I can use the... And I can also see why things are going up in 2s. Yes. Okay, let me stop you. Okay. That's exactly what I want to talk about. And I want to talk about it partly because it seems that what you're all doing is incredibly mathematical. You're noticing patterns and you're wanting to generalize. You're wanting to discover rules. Mathematicians spend a lot of the time noting patterns, explaining patterns. And so here at the front there, you've been talking about 4 consecutive numbers. So I'd like to think about 4 consecutive numbers. And I think you here at the front said there were sort of even numbers. What was it?
Even numbers that when they're divided by 2 equal a constant.
Yes, okay. So, let's see whether we can explain this. I want to give you 2 different ways of understanding what's going on. And I'm hoping you can find this quite helpful and you'll be able to use it to explain some of the other patterns that you're discovering. So I'm just going to talk about 4 consecutive numbers and hope that you'll be able to adapt this for the work that you've been doing. So one way I can describe 4 consecutive numbers is by using 4 bars, each increasing in height by 1. It doesn't matter how long these are, as long as the second one's 1 more than the first, the third one's 1 more than the second, the last one's 1 more than the third. Okay, so these are my 4 consecutive numbers. So what happens if I take this one out of there and I put it here? Well, I have sort of 4 identical bars plus those 2. So if I've got 4 identical bars, that represents a multiple of 4. It's this number repeated 4 times. That must add up to a number in the 4 times table. plus 2 gives me the next even number. That's not in the 4 times table. So, for example, if I had 42, I could say, okay, I've got to take away 2, which are those two there, and then share the 40 that I've got left between these 4 bars. So that would be 10, that would be 10, that would be 10, and that would be 10. And so my 4 consecutive numbers are going to be 1 less, plus the 10, plus the 11, plus the 12. I hope I've explained that well enough. I had 4 consecutive numbers. I took one from the largest and added it to the smallest. I ended up having 4 bars plus 2 extras. If I take those 2 extras away, I then get a multiple of 4. I can share the 4 equally there. To go back to my 4 consecutive numbers, I then need to take one away from there, so that becomes a 9. This one stays as it is. This one ends up being 10 plus 1, and this one goes back to being 10 plus 2. It means that I can start with a much larger number, and I've got a strategy for working out how to write it as 4 consecutive numbers. So, what this has done is it's given me some idea about which numbers can be written as a sum of 4 consecutive numbers. And it's numbers which are 2 more than multiples of 4. If we think about multiples of 4, let's start at 40. Actually, let's just think about even numbers. So we have even numbers. If I take the even numbers which are in 4 times 10, I can halve them again. If the numbers in the 4 times table, it can be shared, it can be sort of split up into 4. So I can halve that, 20, halve that is 10. I can halve that, 22, halve again is 11. Halve that is 24, halve that again is 12. But what you were saying is, these even numbers are special, because when you halve them, you get an odd total. Half of that is 21. I can't halve it again. Half of that is 23. I can't halve it again. So these are the numbers which are 2 more than multiples of 4. So this diagram hopefully helps you understand why I can write numbers which are 2 more than multiples of 4 as 4 consecutive numbers. It means that if I've got a very large number, which is 2 more than a multiple of 4, let's take 880, I know divided by 4, so let's make it into 882. I can now use this model to figure out which, well, I know that I can do it in the sum of 4 consecutive numbers, and I now know how I can go about doing this. I've got 2 at the beginning of there, that's going to give me the 880. I'm going to share the 880 between those 4 bars. 880 divided by 4 is 220. I also know that that's going to be the height of the second number. Notice here that the 10 stayed. So a quarter of 880 is 220. So that's going to be my second number. So my first number is going to be 219, and the next 2. And I hope one day I'll correct if I've made a mistake. But I think that's right. So the fabulous thing about the generalizing that you've done is it gives you some indication of what's going on. The fantastic thing about images like this is that it helps you then work out without having to sort of try again and again to get closer and closer to the answer. Now, there was a young man there who was using algebraic notation. So let's look at this. So you might be wanting to describe 4 consecutive numbers as a plus 1, a plus 2, a plus 3. So we don't know what a is. It's a variable. It can be any number you choose. The next number is 1 more than a, the next one's 2 more than a, the next one's 3 more than a, and so you have 4 consecutive numbers. Now what happens if we add them? If we add them all, we get 4a plus 6. Does this tell us the same story that the diagram told us? Well, we know that this is a multiple of 4, but what does adding 6 do to this? Well, what we can do is 6 into 4 plus 2. And now we're getting the same result. We've got a multiple of 4, plus 4 gives us the next multiple of 4. Plus 2 gives us 2 more than a multiple of 4. That's exactly what we're getting here. The other nice thing that this does, but perhaps this doesn't do quite as well, it also tells me that these 2 numbers in the middle add up to the same as these 2 numbers at the end. So in the middle I've got a plus 1, and a plus 2. At the end I've got a and a plus 3. If I add these together, I get 2a plus 3. If I add these 2 together, I get 2a plus 3. Now why is that useful? Well, it's useful because when you give me a number like 42, I think to myself, if I halve it, I then know what my middle pair's got to add up to. So 42, half it is 21. Oh, I know what 21 is. 21 is 10 plus 11. And that also tells me that the two numbers on the outside are up to 21. That can be 9 plus 12. So the algebra sort of tells me something that perhaps this didn't do quite as easy, quite as well. It gives me some idea about how the numbers work with each other, but it also gives me a strategy for working these numbers out really, really quickly. So let's do the 882. So we have, I did half that, and that's going to give me 441. And now I'm thinking, okay, so the middle pair, I've got it up to 441. So that's 220 plus 221. And now I know that if I take one away from here and I add one onto there, I'm going to get another two numbers, but also that up to 441. I want to talk about mathematicians being lazy, and this is sort of a form of laziness.